Hey, what's up everybody? I'd like to welcome you to another Juice tutorial, and today what we're going to do is part 2 on our Metronome class. So if you watched part 1, essentially what we did was we created a class where we were able to import some of the variables that we needed to calculate our beats per minute, stuff like sample rate and buffer size. And we essentially had this method called count samples, which we put into our audio block, where we are able to count the number of samples that are being processed through the audio block when the play state is playing. And we created a play button and a stop button to start processing those samples or to stop. So what we're going to do this time around is we're actually going to calculate beats per minute, and we're actually going to look at if we had a sound that was going to be giving us some type of click or some type of indication of when the beat is actually hitting. What we're going to do is calculate when that actually needs to happen. Okay, so before we start, be sure to check out our Patreon if you want to support the channel and you're finding these tutorials helpful. And also, we're going to be offering some premium courses soon, so be sure, if you're interested in that, to sign up. You can sign up on theaudioprogrammer.com/sign up. The link is below for both of those. So let's go ahead and get started. So what we have, first thing I'm going to do is I'm actually going to just change the convention of these to all of the same thing. So I'm using this little M to mark our global variables, and I'm just going to do that here in all of our variables here. So play state would become M play state, metronome would become M metronome, and then we just got to update all of these things here. So we also have play button and stop button. So we got M play button, M stop button. I'm just going to do that quickly. So it's just good to keep the coding style consistent here when we're doing this. So I'm just going to do this quickly. Okay, now that we've done that, we're back in our metronome class, and what we're going to do is now start looking at how to calculate the beats per minute. So there's a known formula for calculating beats per minute, and it's 60 seconds over the BPM times the sample rate is our formula. So we're going to go ahead and integrate that first. So what I could do, I could just do I will do a int, and this will be called M interval. I'm just going to put it as a default to 0. And while I'm here, I'm going to do an int BPM. I'm just going to put that to 0. So I'm going to go back here. And so now what I could do is I could say M interval. So let's talk about what we're doing here. So I'm going to actually put this below my sample right here. M interval. So what we're doing here is we have these samples, the buffer samples that are coming in as we're counting them. And what we need to do is we need to calculate at what point do we need to give an indication that we are on the beat for the BPM, because you know how in a DAW you have a metronome that has a counter, right? So we need to know when that counter actually needs to play. So the way we could do this is we could say the M interval is equal to 60 seconds over the BPM times the sample rate. I'll put M sample rate here. Okay, so let's go through that really quick. So and what I'm going to do is I'm actually going to give this BPM just a default value. I'm going to put it at actually 60 because this really makes it a lot easier to understand. So let's say that we have a 60 BPM track, or that we are setting a project to 60 beats per minute. Well, if we're looking at 60 seconds and 60 BPMs, well, it's gonna beat one time every second, which means that it's gonna beat once every 44,100 samples, right? Because our sample rate is probably going to be 44,100. So that makes it nice and simple, so we can actually kind of see when our samples, when our interval has kind of passed. Okay, so like if we look at 90, let me give you another example here. So I'm going to pull up a calculator, and hopefully I don't make this explanation too confusing. So if we look at let's say 90 beats per minute, right? So we would say 60 divided by 90 equals 0.6 repeating, right? So now we got 0.6666, and then we multiply that times 44,100, and we can see that we come up with a number 29,397. Now, let's just think about that intuitively, and we can see that makes a lot of sense, because if we're on a 60-second clock and we're going 90 beats per minute, well, because 90 is greater than 60, then we know that the beat is going to land faster than 1 second, right? And that's what we see here. We see that every 29,397 samples, there's supposed to be a beat or a downbeat. Okay, so that kind of makes sense intuitively, and we can see that using the 60 beats a minute as well. 60 over 60 is 1, and once again, we're going to be on the downbeat every 44,100 samples. Okay, so now how are we going to actually calculate that? So what we could do is we need to have some type of timer. So what if the person is working in the project, and in the middle of while it's playing, they change the beats per minute? Well, we need to be able to update what the beat per minute is and be able to recalculate what our interval is. So we can create we can use a timer to do this, which would update regularly, just to make sure that the BPM, if there are any changes, that would reflect in the updates. So if we go to our Juce API here, and we can see that I've been looking this up. So this is actually a one page where I found this formula here. So this gives an explanation. I'll put the link to this in the description below. So here we have a what's called a high resolution timer. So what we want is a timer that's going to be sample accurate. And so you have two timers. You have a regular timer and you have a high resolution timer. And for this case, I would want to use a high resolution timer because we want this to be sample accurate. Okay, so what we can do is we could just go ahead and inherit this class. So here I can say public high resolution timer, and then here I will just say, so here we have a virtual method that we need to implement here, and we know that because it has this equals 0 at the end. So that's a virtual method that we have to implement in order for that to work properly. So we say void high resolution timer, and then override, and we mark it override just so we know that we're overriding the class and letting any readers of the code know that this is a pure virtual function. So now we need to implement this, and so we could say, I'm going to put it below reset here. So we got void metronome high resolution high res timer callback, and then what I'm going to do is I'm just going to put this in here, It says high res out of line definition. So let's just make sure. So I think this is high res timer callback. Okay. So I'm just going to compile this really quickly, make sure that this actually works. So we see that this needs to be a double here. So we can just change this to double. I'm just going to keep it an int and just remove the 0.0 here. Just keep it nice and simple. So there we go. So now we have our high resolution timer callback. And then what we could do is we could actually start the timer in our prepare to play method here. So we need to use this abstract method high resolution timer because we're not, and it's abstract because we're not actually creating an object of type high resolution timer. Okay, so that's why this is an abstract method, and we can do this. So we're basically stating the class and saying start the timer, and then I'm just going to pick an arbitrary number here. I'm just going to put 60 milliseconds here. Okay, so that's fine. Now we have our interval in place, and that's all good. So now we need to take a look at, okay, well, how are we going to calculate when the beat is actually on the downbeat? So we could say, let's have a look here. So we have this number total samples that's calculating the samples as they're coming in from the buffer. And now what we could do is we could say, okay, well, if we could use a modulo function, okay, and we could say if the interval, so once again, we're at 60 beats a minute, and we could say, okay, if the interval is, if the total samples is more than the interval, then we want it to do a downbeat, right? So we could say, let's see here. So let's just type this out as we're actually doing it here. So we got if the m total samples, and then we got modulo, which is very important. Don't be scared of the modulo. Okay. And so m total samples and m interval, so m total samples modulo the m interval will give you the remainder, right? The remainder of how many samples are left to process before we're supposed to hear the next downbeat. So we could just call this m samples remaining. Okay, and I'm just going to make this a global variable of type int. Okay, so there we go. So once again, we're just calculating the modulo. So the modulo is going to tell us how many samples are remaining before we get to the interval, which is 44,100. Okay, and now we just need to type this out in code. So we go if, so we need to look and say if the samples remaining is greater. So let's see here. Let's think about this. If m samples remaining is greater than or equal to the interval, then we want it to click, right? So because let's think about this. So the total samples is going to be going up. Total samples is going to be going up. M interval is going to be staying the same. So the number is going to be rising. M samples remaining is going to be a rising number, right? And we need to calculate when that goes over the interval. So that seems to be right to me. So what we could do is we could just console this out for now, right? So we know that this is going to be when it clicks, And then what we want to do is we want to look at, let's see here. So we could say we want to look at the M total samples, right? So we'll just say total samples, and then M total samples. And that will let us know how many total samples we're at when it actually clicks. Okay, so this looks right so far. And I'm just going to take this out. And let's see how this works. Okay, and another thing I'm going to do is out here, I'm just going to put another console out. Let's do M samples remaining. So we say samples remaining. M samples remaining. And then we will do interval. So beat interval. And we will do interval here, just so we count, so we could console this out just to see what values are actually happening. Okay, so now I have my metronome. We see nothing is happening here. I'm just going to actually just give us a little bit more room, and then I'm going to do this, and now I'm going to hit play. Okay, so now we've played a couple of values more than a second. So let's see what happens here. So once again, we're at 60 beats a minute here, and we can just take a look here, and we can see that our samples remaining is adding, and that our interval, so something's supposed to happen once it gets more than 44,100 values. Okay, so we went a little bit too far. Okay, so now we have samples remaining is at 43,000. This is at 44,000. And then it goes here to 44,032. Then it resets. Okay. But we see that, okay, so this didn't execute when M samples remaining was more than the interval. Okay, well, why did that not happen? Okay, so we can see that the beat was supposed to happen here. It was supposed to click here, but it didn't. And the reason is because what's happening is when we add the 512, so when we're at 44,032 values, when we add the 512 to that number, what's going to happen is that it's going to reset and go back to 0 again, isn't it? It's going to go back to 0, and then what we have is the remaining of that 512, which is 444. So we have a problem there, and what we need to do is we need to actually fix that. So we could actually fix that by saying by just kind of preempting what would happen the next time. So if we say M samples remaining plus the buffer size, I'm just going to use M buffer or buffer size. Okay, is greater than the interval. So if the samples plus the buffer size, so if we have 512, and if the samples remaining plus the buffer size is greater than the interval, which is 44,100, then we're supposed to get the click, and that's supposed to be a downbeat. Okay, and we can see that should work. That should work, because what's happening there is that we're saying, okay, so we're at 44,032 values here, and that if we were in this if statement here, that if we added 512 values to that it would execute this statement here. And then the next time around, we would be at 444. So that should happen. So let's go ahead and give that a try. So here we are, and we're going to hit play. And I think in my console out there, I thought I saw a click there. So let's have a look here. So we could just look for where it says click. Okay, and we'll look at this. So perfect example right here. So we have samples remaining is 44,032, and then what happens is that we get a click, and that the total samples is 44,032. So let's make sure that that's actually happening. So if this is true at the very start here, we got 510, 24, 15, 36, so on and so forth. This is going down, down, down. When we get to a second in, which would be 44,100 values, we should have a click, right? So here we are, 44,032, and boom, we have a click. Okay, so that seems to be working right. So let's just change it really quick to 90 beats per minute, see if that happens. So if I remember right, our number of values when it's supposed to click is supposed to be around 29,397, I think it was. So let's go ahead and have a look at that. Let's see if this works properly. Okay, so let's stop it. Let's search for where it says click. Okay, and there we are. We're at 29,184 values, and then if I'm just going to go back here to the function itself, and that if we're at 29,184 values, and if we added 512 values to that, that would bring us over 29,400. And that's what we're at. 29,400 is our interval, and we can see that we have a beat click. Okay, so obviously we aren't hearing any sound yet. What we have to do is we have to load a sound and actually have it trigger here. So that seems to be working fine. And yeah, so that's all good. So that's where I'm going to stop for this one, because we went through a little bit of just theory on that one. And I hope you found this video enjoyable, and be sure to like and subscribe if you found it useful, and we'll see you next time.